Have you ever helped a friend move and you find yourself completely stuck trying to pivot this massive overstuffed sofa up a narrow stairwell?
Oh yeah, the absolute definition of a logistical nightmare.
Right. Now imagine that exact same nightmare, but instead of a couch, you were trying to maneuver a rigid 19-foot wide display screen into a corporate elevator.
Which, I mean, you literally just can't
It
do.
really can't. So today we're taking you on a deep dive into a product spec sheet from HDTVSupply. We are looking specifically at the Draper 254-256 Profile Plus fixed frame screen.
And at a little over $6,300, this is a serious piece of commercial AV hardware.
Exactly. And our mission today is to figure out what actually goes into a high-end display like this and why it is an engineering marvel, not just a giant, very expensive bed sheet. So, okay, let's unpack this.
Well, let's start with the sheer scale. We're talking about a screen that is 226 inches diagonally.
220.
Yes, 120 inches by 192 inches. It's in a 16 by 10 widescreen format.
Which brings me right back to that stairwell analogy.
Yeah.
You literally cannot get a 19-foot solid frame into a standard elevator to reach, a church sanctuary or a training room.
The physics of doorways just won't allow it.
Yeah, the engineers knew the biggest hurdle was exactly that. So the logistical solution, it ships entirely unassembled. It is essentially high-end flat pack.
What's really fascinating here is the mechanism they use to make that modularity work without sacrificing structural integrity.
Because you'd think a snap-together screen would be flimsy.
Exactly. But it utilizes a lightweight aluminum frame that snaps together, combined with this highly specialized sliding hook and loop system.
Wait, like industrial Velcro?
Sort of, yeah. Instead of fighting with traditional industrial snaps that can warp the material if you pull them unevenly, the hook and loop allows the installer to incrementally tension the screen across the frame, right there in the room.
Okay, but if you're assembling it on-site with hook and loop, I feel like that brings up a massive structural question.
How so?
I have to push back on the framing design here. If venues are placing multiple of these screens edge to edge to build a mullion-less video wall with zero separation.
The seamless, borderless look, right?
Right. Isn't the screen material going to sag or stretch at the seams over time without a traditional heavy border holding that tension?
Well, that is the exact engineering challenge of the zero-edge design. The solution actually comes down to extruded aluminum baffles.
Baffles.
Yeah, the frame doesn't sit flush with the edge of the viewing surface. Instead, those aluminum baffles sit just behind the viewing plane, stretching the material over a chamfered or angled edge.
Ah, so the tensioning happens completely out of sight, just wrapping slightly around the back.
Precisely. It pulls the material drum tight from behind, keeping the entire profile under 2 inches deep.
Wow, under 2 inches.
Yeah, that means you get no thick, distracting border breaking up the visual space, allowing for one optically seamless visual field out of separate modular units.
So the frame solves the geometry problem of putting multiple screens together, but a massive video wall is basically useless if the image looks terrible under harsh corporate lighting.
Which brings us to the actual viewing surface itself.
Right. The spec sheet lists a gray XH600V surface rated for 1080p front projection with a very specific 0.6 gain. Now, anyone who has built a home theater knows you use a gray screen to reject ambient light.
For sure.
But dropping the gain all the way down to 0.6 for this surface, I mean, that is a really aggressive light swallow. What specific environment demands that much absorption?
If we connect this to the bigger picture, it is all about absolute contrast control. To quickly ground the jargon, gain is just a multiplier for reflectivity.
So a standard white reference screen has what, a 1.0 gain?
Exactly, meaning it reflects light equally. By utilizing a 0.6 gain, this Draper screen is intentionally eating 40% of the light hitting it.
Right, because in a sports bar or a brightly lit megachurch, you can't exactly turn off the overhead lights.
Can't. And if you project onto a 1.0 gain white screen in those rooms, the ambient room light just washes out the dark parts of the image into this murky, faded gray.
Oh, yeah. Nobody wants to watch that.
Definitely not. So the 0.6 gain gray surface absorbs that ambient scatter. You pair it with a massively bright projector, and the screen ensures the blacks look deep and crisp. It's not about maximizing the light, it's about controlling it.
It really makes you rethink what goes into these installations. The next time you walk into a venue and see a massive, flawless display, hopefully you will appreciate the hidden engineering behind it.
From the 5-year warranty backing it up.
Yeah, to the sliding tension systems and aggressive light-swallowing physics that make the image pop.
This whole thing raises an important question to mull over.
Oh, what's that?
If we are already engineering perfectly seamless, less than 2-inch deep displays that can be tensioned on-site with zero-edge separation, how long until we stop hanging screens entirely and our architectural walls simply become the display surfaces themselves?
Wow, no more pivoting giant frames up the stairs, the wall just wakes up. Now that is something to think about.